So Dr. Guiomar Niso is an AXA postdoctoral researcher working at the Universidad Politécnica de Madrid. Her research uses neuroimaging to study health and diseased brain states, including epilepsy, Alzheimer's, and blindness. She has contributed to several open access initiatives, including pioneering open data repositories such as Omega, open software initiatives such as Brainstorm, as well as open standards, including BIDS, in order to foster reproducibility and transparency in neuroscience. Currently, Dr. Niso is chairing the BIDS steering group, and her talk title today is BIDS, a data standard to support the neuroimaging community. So, Dr. Niso, the floor is yours.
Thank you very much, and thank you for inviting me to this really nice workshop. I'm learning a lot, and yeah, my experience is with open science is mainly related to BIDS, well as these other open databases, but everything is at the end related to this standard, because this is a standard to support the neuroimaging community. And I'll go, yeah. Let me, sorry. I'm going to remove these things here. Okay. So, sorry. The human brain is such a complex system that needs from multiple scientific tools to be, and from multiple scientific fields and knowledge to be understood. So ranging from biology to medicine, to psychology, to pharmacology, to engineering. So the human brain has millions of interconnected neurons, and each of them has thousands of connections between others, among others. So all these huge kind of information that there's in the brain, that there's going on in the brain, needs really a lot of tools to try to understand what's going on. So thanks to MRI, magnetic resonance imaging, using strong magnetic fields, we can create detailed images of brain tissues. So another technique is like functional MRI, which is able to detect changes related to blood flow, which are usually linked to neural activity. PET, which is positron emission tomography, detects changes in metabolic activity using radioactive substances that are called traces and produce these kind of images. And MEG, it's an electrophysiological technique, but also can be considered neuroimaging, detects the magnetic fields generated by the underlying neural assemblies in the brain. So we have these kind of signals, record like brain oscillations that can also be mapped into the surface of the brain. And the same happens to EEG, which detects the electric potentials differences between pairs of scalp electrodes, and also gives you time series, which are also, that can also be mapped to the cortex surface. Intracranial EEG can be done through electrocorticography, like with electrode grids, and stereotactic EEG with some deep needles also gives you some kind of brain activity, even though it's more located to the point where the electrode is. So with all these techniques, MRI, PET, MEG, EEG, intracranial EEG, and many more, we can have an idea of the huge amount of data that we have in the community, and the huge amount of parameters of metadata, of details that each protocol has. So we have to converge into something to try to organize and describe this data properly. Also, nowadays there are more and more databases which need also can benefit from these common standards. So this is the BIDS. The BIDS is an imaging data structure that is just a standard to store, organize, and share your neuroimaging data. Why is it needed? This could be a potential situation in the lab. This is Professor Smith. Hey, I need to ask Mike about this old data. There's so much more we can do with it. But meet Mike, he doesn't longer work in the lab. So Professor Smith really needs a lot of help. What's the problem? The problem is data is organized differently between institutions and even within a lab. So this produces a suboptimal use of resources. A lot of human resources with a lot of time trying to retrieve and rearrange data. Infrastructure, because we need disorganized data, produce a lot of duplicates and data storage space. Also financial, because when data is disorganized, it has very limited longevity after the first, and very limited value after the first publication. And on top of that, we have really poor reproducibility of results, even within the lab where data were collected. So with the BIDS, we tried to deal with some of these issues. And what's BIDS mainly is just a way of organizing like similar categories and describing with labels and with metadata what's inside, what's your data set. So BIDS is based on very simple file formats and folder structures. It's worth mentioning that BIDS is not a file format, but it recommends which file formats to use in every case. For example, Nifty, JSON files, DSE. It also gives you suggestions, a recommendation about naming conventions for files and directories. And the most important, it prevents your metadata getting lost while doing research. There's a maximum, and it is that some metadata is better than no metadata. So whenever possible, all the metadata available should be stored in JSON files, which are readable both by humans and machines. This has a really big advantage, as nowadays we want to see what's in the data and we want to read it, but also there are all these automatic pipelines on machine learning and automatic queries that wants to just have access to the metadata in an organized way. So the key principles behind BIDS are adoption, the first one, which is crucial. We want to minimize complexity and facilitate adoption. So we don't want to reinvent the wheel. We want to reuse existing methods and technologies whenever possible. Another key rule is the 80-20 rule, which tackles 80% of the most commonly used cases. And finally, the engagement of the global neuroimaging community. The input of the global neuroimaging community is really important, especially during the creation of the specification. So, why is it needed? Should I use it? Are you acquiring human neuroimaging data? Are you a PI and want to ensure your students and postdocs document their data so other members of the lab can reuse it later? Are you a researcher planning to share your data with others? And do you want to avoid having to call the scanner manager to figure out what was done a long time ago? And finally, is this how you feel when working with data acquired with someone else? Or even worse, is this how you feel when trying to reanalyze data acquired by you a long time ago. If this is the case, you should definitely use BIDS. BIDS has benefits, as we have seen, for researchers. It's easy for other researchers to work on your data. For PIs, if you're running a lab and you anticipate more than one person will be working on the same data over time, then it's really beneficial to use BIDS. Also, there are a growing number of software packages that can read data in BIDS. So this can facilitate analysis and pipelines and speed up the process of the analysis in your study. Also, if you ever plan to share your data publicly, nowadays some journals require this, you can minimize the additional time and energy spent on publication and speed up the curation process. For example, OpenNeuro accepts data in BIDS. And finally, validation tools, because BIDS Validator can check data integrity and help you easily spot missing values, which could be at the end very beneficial for you to have a very complete data set. So this is a practical example for MRI. This is how the data comes out from the scanner, and after BIDS, you will have this organized in subfolders, and with a naming convention on it. Well, this is a funny meme created by Remy on Twitter, and he says, well, this one doesn't spark joy, and this one sparks joy. So it's this. And let's go like in a detailed example data set. You will have my dataset folder, and inside this you will have some description files like participants TSP or JSON dataset description. Then you will have your subjects and your sessions inside your subjects. And if you go to the participants, this is what you have inside. It's just like a TSV file with some keywords like participant ID, age, sex, and just like very simple. And sometimes it's also recommended to have an adjacent JSON. So you can, maybe these are very obvious, but this participant TSV could get at sometimes a bit more longer and larger and more complicated. So it's good to have a description like age of the participant, or sex as reported by the participants, and the options you have, and like this. Also, you will have your dataset description JSON file, which just gathers the name of your experiment, the BIDS version, the dataset type, and all this, how to acknowledge, funding, and dataset DOIs, and references. So all these keywords are fixed, and you only have to fill in. If we go into more detail, you can, for example, inside one section of the subject, have like anatomical data, like coming from a T1, from an MRI, or functional, or diffusion, or MEG, behavioral. So all these are also accompanied, every data file should be accompanied by a sidecar JSON file, with gathering all the metadata. For example, for this anatomical data, you will have like the modality, magnetic field strength, imaging frequency, and all these sequence parameters. So if you go into the MEG, then you'll have like also the institution name, the manufacturer, like sampling frequency, power line, and dewar position, recording duration. All this is gathered in the metadata JSON files. This is why it's becoming very useful and to have a very complete data set. All these details are in the BIDS specification, which can be found online. And you can have all the fields and keywords there, like if it's required, if it's recommended, and if it's optional. So you can have a really, your data set has a lot of integrity and feel. So the BIDS standard started for MRI and fMRI in 2016 by Chris Gorgolewski, and in Russell Poltrack lab. and it's got extended to MEG, also to EEG, and to intracranial EEG. So each of these modalities has their own specific fields and parameters, and there are more to come. So who is this BIDS for? So it can be used for lab PIs and researchers because it's easy to transfer a dataset from one student or postdoc to another, or it's also useful for workflow developers because it's easy to write pipelines, expecting a particular file organization. I have a beep. Well, I guess it's something not related. So it can be useful, yeah, as we were saying, for workflow developers, because it's easy to write pipelines expecting a particular file organization. And also for database curators, because it's easy to curate when you have a given format. But the BIDS, it's something beyond the specification, and it's the community. BIDS is a community-led standard, so it's the result of ongoing collaboration of amazing people like you. So the specification is created after sharing knowledge and discussions and consensus through the email discussion list, through the Shell Google Docs, and through GitHub. So we have a GitHub page where all the updates are being taken into account, and PRs, and we have also now a well-specified governance structure. Whenever someone wants to extend the BIDS standard to include another modality or another thing that could be interested for the field, they create what we call BIDS extension proposals that are called BEPs, and each of them has a leader. So we will see at the end how many open BEPs are currently going on in the BIDS community. And yeah, for example, let's say you want to extend the standard to PET, then you create a new BEP and people start collaborating there. And finally, we have a steering group. This is our current steering group. We are people from around the world. Each of us we have expertise in one modality, in specific modalities, and we were elected by a consultation to the community, and we also have a really good team of BIDS maintainers like Stefan, Chris, and Franklin. And yeah, any of you can become a BIDS maintainer, and any of you can be part of the community. BIDS is a very open and inclusive community. It has hundreds of people collaborating, and you are really welcome to join and contribute. Where to start? We have created a BIDS Starter Kit to join the BIDS community. You can find it online, and contributions can be made at all levels, like introductory, intermediate, and expert. So don't feel afraid of contributing or thinking that you don't have knowledge enough to contribute, because everyone can contribute, from documentation to more expert and advanced things. So we also have our BIDS Validator, which is, I think it's key in BIDS, because it can check, it enables to check your BIDS dataset. And this is the online versions where you can upload your BIDS dataset, and it gives you the errors or the warnings. And so you can check your dataset integrity and spot missing values. So this is a really, really nice tool for the community. And talking of tools, we have like multiple tools and converters to make it easy for researchers to incorporate BIDS into their current workflows and to maximize data sharing opportunities, for example, via Open Mural. These are like all the we have gathered all the tools we have. These are converters. There are also institution-specific data management tools or converters, quality assessments, and other tools. And this list keeps on growing every day. So it's really cool to see how the community is growing. And yeah, and also we have BIDS. There's another part of BIDS, which is the BIDS app. And what's a BIDS app? BIDS app is just a container with a neuroimaging pipeline that takes bits at a dataset as an input. So the input is a bits dataset, and it has the same core command line arguments. So it's easy to integrate in automatic platforms. So it doesn't depend on any software outside the container. So it's very useful. We used two technologies for container computing, which is Docker for building, hosting, and running containers on the local hardware like Windows, Mac OS, or Linux, or in the cloud, and Singularity for high PCs. So this is something really cool going forward, because here we forget about any software dependencies. We just create like a box and you put inside your pipeline, and you can, and because the input is in an standardized way, you can from there go into more automatic pipelines. So they are openly accessible, which are deposited in the Docker Hub repository. We have version control. Each BIDS is versioned, and all of the historical versions are available to download. And really important, like reporting the BIDS app name and version in a manuscript can provide others with the ability to exactly reproduce and replicate the analysis workflow. So I think this is really a cool part of BIDS too. So these are all the available BIDS app. Yeah. To finalize, I just wanted to say that a global community of over 200 people created BIDS standards for many neuroimaging modalities and more to come. So everything started at MRI at the Polchak lab with Chris in 2016, but then really soon it got extended to MEG, which I was proud to contribute. And MEG is like the ground for electrophysiology techniques. So all other techniques like EEG and intracranial EEG also emerged and created their standard. And also there are standards for task events, for physiological metrics, for behavioral, and for genetic descriptors. This just very recently emerged. And many more to come. So there are so many other modalities that are being in the process to being created. Like very recently, we just incorporated the provenance execution and motion data and NIRS. So if you resonate with any of these, please go ahead and join and contribute. Or if you think you can propose a new one, please also go ahead. And we have the derivatives, which are up to here. We're focusing on raw data, but we also want to extend the standard beyond that, to see how to organize the data once it's becoming pre-processed and processed and analyzed. So we just, like a few weeks ago, merged the common derivatives standards in BIDS 1.4. So this has become like a basic pillar where all the other derivatives will start to hang. And yeah, over the last year, we have like many actions, and that were really well summarized by Chris Markowitz, one of our BIDS maintainers. And on the OHBM Open Science Room BIDS community town hall. So you can see here his slides and probably also the video recording if it's available openly. And here Chris goes through all the open webs, what are the status currently, and some future points. So organizing your data in BIDS is good for future users, but also very good for future you. So please join the community and join the StarNet and help and contribute. Thank you very much. We are like a big community. Thank you to everyone for listening and to all the contributors to this.
Thank you very much, Guiomar, for this very interesting talk. We will be monitoring for questions for a few minutes here. There's a question from Guiomar Niso.
Yes, thank you, Guiomar, for your wonderful presentation. I get you just very briefly mentioned integrity. So I was wondering if this is a good tool to ensure integrity in research and increase transparency of what someone is doing on data. And if yes, can you say something more on this?
Yeah, I think the BIDS Validator, when I was referring to integrity, is like, for example, if in your metadata there are some fields that the standard considers that are compulsory, then it's going to warn you, and it's also going to make you aware, oh, I haven't reported that. So it's also very useful to don't forget things and don't forget to report things. So in that sense, it's quite good. For example, if you haven't put like the sampling frequency, or maybe you already know because you have collected the data, but in 1 year from now, maybe you have forgotten, or if someone else wants to reanalyze your data, it won't be able to do it unless they call you and say, oh, can you remember what was the sampling rate of your data? Or, well, I say this field, but there are many other fields that are also so. So I think some people say that the BIDS is the validator because the validator is the tool that integrates all the knowledge from the specification and makes the people, like in a practical way, to have a feeling of if their data set is complete or not. So, well, I don't know if this answers the question.
Yeah, thank you.
A question from Vittorio Covella.
Hi, thanks for this nice talk. It's always amazing to hear the story of this community effort, which I think is changing the neuroimaging community from its foundations. My point would be whether you have a suggestion or just a comment about when it's useful to adopt BIDS. If it's something that you should adopt by default before starting your acquisition. So maybe instead of having like your lab notebook, you have automatic forms which grab information and so on. Or if it's possible also to BIDSify all data sets, and whether like the learning curve to BIDSify data sets is not worth it, and it's better to start from scratch and so on. Thanks.
Well, I would say that the sooner you adopt it, the better, because then you are on track. It's also possible to do it backwards. So there are many converters that can convert. So that can convert like imaging bits or DICOM or to bits or all these tools. But we were discussing that because one of our future aims, or what we are trying to start, we are actually fighting for it. It's like that the BIDS becomes such a standard that the manufacturers themselves consider to give their data already in BIDS. this would really advance the field, and it will be like something changing. But still, even if this is not the case, it's really easy to if you manage, if you are running a lab, to ensure that like a really start from the beginning and ensure a really complete way of recording your data and to document it in your metadata. So all the questionnaires that can be, for example, we were working at the MNI. I was working there in Montreal. So we organized like a way of, once you acquire your data, you have to fill some questionnaires and automatically it fills all your metadata and all your files. So if you can do this at the beginning, it will be then really easy to go forward. But if not, there are always BIDS converters. And as we were saying, because this is not a new file format, it's just a way of organizing your data and document your metadata. It doesn't have a really big learning curve. It's something quite immediate. It's instead of, maybe people already call their subjects like subject 1, but then if you say no, that you have to say sub -01, then for you it's almost the same. So, but at least then all your data is BIDS compliant.
Yep, thanks.
Clearly, there's a lot for the single investigator in BIDS in terms of maintenance, transparency, and provenance. But where are you taking the standard in terms of capitalizing on its ability to actually aggregate information from multiple labs in this sort of semi-structured representation? So clearly now you can actually take BIDS information from any labs, store them in databases, and allow people to search on them and have particular views into related. So basically data discovery. So how are you working in this area of actually collating BIDS information from multiple labs and storing them in the same place so they can be aggregated and reused?
Yes, maybe I didn't make it that clear because we are in the field and we already know, but there's a really nice web platform that is called Open Neuro, and where you can really upload your data in BIDS format, and then you can query it. You can, like, people from all over the world can upload their data there. And one of the conditions to upload your data is that it passes through the BIDS Validator. So once it passes through the BIDS Validator, the data is aggregated there.
I'm sorry, I think I wasn't clear in my question. So I wasn't asking about OpenFMRI, Open Neuro. I was asking more about a repository of just the metadata. So basically having some sort of database that just stores the JSON files and the organization without any raw data that can serve as a pointer for data residing elsewhere in multiple repositories. So Open Neuro has tuples of BIDS data, file descriptors, and raw data, but are you thinking of some environment where there's going to be only the metadata that can live separately from the raw data?
I wasn't thought about this. What could be the point of that if you can have both?
Well, the point is it can be distributed. So it's like a DNS, the domain name system of the internet. It doesn't save the IP addresses and the translation of the names with the actual content. It knows, basically allows you a way to search and query for information. And once it finds a lookup, it sends you to the actual IP address where the content resides. So once you have a distributed engine, you keep the metadata with pointers in one place, and you keep the actual data in others, so that you can have different models of the relationship between managing querying the metadata and where the actual data live. That's the only reason.
Yeah, I haven't thought about that. I think it sounds interesting. I don't know. Well, the BIDS community is huge, so maybe some of the people already know of something for that, but it looks like, yes, like a good idea. Yeah.
Okay, thanks. I was just wondering. Thanks very much.
Thank you.
There's a question from Alessandro Dodic.
Thank you very much for the presentation. I was wondering if maybe you mentioned, and I didn't catch it, is there a way to like create like a project in which different labs share images, upload or download images if they work together on a specific project?
Yeah, I'm not aware.
So in BIDS, basically, can you send images like through a link, or can you share the images you upload with another group, for example, if you are working together on a specific project?
Yeah, I think that when BIDS is not a platform or anything, it's the way you organize your data and you describe it. So there are, usually when you are in a project, you usually have like your tools. So even if it's, let's go super basic, but upload this to Dropbox or Drive or FTP server, you can just share the link. And you are talking about another platform where you can upload your data and collaborate with but exclusively with your collaborators, right?
Yeah, exactly.
Yeah, I'm not aware of anything like this, except their own initiatives platforms. For example, if I am working with a team, we got a project, usually we make our kind of a related thing or a related way of collaborating, and I usually like create a folder and share, but there's not like a platform like that. And for what I remember when I was working at the MNI, this was one of the projects that they wanted to do inside the institution, like to create a platform that you can collaborate with other departments and other groups, but not everyone can see the data because of the privacy reasons, but you can share things with your collaborators, like internally. And it was also following the BIDS specification. So, but I don't know of any like huge like public platform to do that, other than the ones internally created by institutions or projects. So, but it's really, I think this would be a really cool idea to implement.
Thank you very much.
Thank you, Alexander.
Okay, so given that I see no more questions, I'll take the opportunity to thank again Dr. Niso for the very interesting presentation, and all three speakers of this morning session for their time and for their expertise. And we will resume the sessions at 2:30 in the afternoon, Central European time. So we hope to see you then. Have a good afternoon.
Thank you.